Um, Hello, I'm Geoffroy Coupry. I'm going to talk about parser combinators in Rust. I'm sorry, still some problem with the slides. Okay. I'm the security guy at Clever Cloud, a French company doing platform as a service hosting, like Heroku, but better, just like that. I also do some consulting. Basically, why are we talking about GNOME, which is that cute Parser Combinators library I'm doing? Well, it all comes from small projects that is kind of dear to me. I've worked for a few years for Videolan on Windows development and security, reverse engineering some formats, that kind of stuff. VLC has a big problem. Is that it's the software that should handle all the formats that exist. Like to throw any video, any streaming format, it should work. So it's good, but there's the bad part. We have lots of vulnerabilities. What's interesting here is that the MP4 format, it's one of the most ambiguous formats we've seen. It's very hard to write a good parser for MP4. But on the other hand, we have a parser for Matroska, the MKV files, which is very big in a lot of files, but nobody seems to have found any rules. Maybe check yourself. Some of these rules can just be found by simple fuzzing. So you always find a crash somewhere. The problem is we have to write C parser by hand. So that's not something we like. So we need some kind of more practical solution. What I would like is something that's memory safe, efficient enough for streaming, and embeddable in C. That kind of requirement is important because otherwise I would do just some Haskell. But the runtime with the garbage collector and everything is just too big for what we want to do. So I investigated the Rust language that has been developed by Mozilla. The 1.0 version was released just last week. So hopefully now they will stop breaking the language every 2 weeks. Yeah, I've been developing GNOME since October last year. And at some point, but just every 2 weeks, something crashes and you have to start over. But right now, it's very, very stable. So a few highlights on the features of that language that pushed me to choose it. So basically, they want to manage the memory directly in the compiler. Because as a developer, as a C developer, I suck. I don't know how to develop a parser correctly. So I make mistakes and I make memory leaks. And so I shouldn't manage the memory myself. So basically, in Rust, the compiler knows at any point in time who owns a variable and when it should be deallocated. Basically, you could write some data sharing between threads, but it will know which thread owns which variable. No need for mutaxes or anything like that. So that's quite powerful. There are other features that are interesting. You can manipulate slices instead of buffers. A slice is just a structure containing a pointer and a length. So maybe I thought, what can we do with Rust? Well, we could do some zero-copy parsers. Like at the end of the passing, we just have pointers to the relevant input, and we don't copy anything anywhere. So that was a big bet, especially in last October when the language was not that ready. But, well, I tried. It was cute. It was fun. And here's how it looks. So as we can see, is that big enough? No. OK. Just there? Yeah, that's better. So first thing to see, Rust is a language that has generics. So this is good because as you see in the first enumeration, the R result, the result of parser, we have down, which contains a part of the remaining input and the output type. Most of the time we manipulate byte arrays, but we can manipulate anything. I'll go after on the error and incomplete part, but basically we need a way to represent correctly errors, and we need to represent incomplete data, because sometimes just a parser knows that it must have more data. So how do you write a parser? It gets a bit hairy. Basically, what we can see at the apostrophe A indicates the lifetime. This is very powerful because you see that the output data has the same lifetime as the input data. That's how I can make sure that data is not copied and it's just a reference to the input. What do we have on the other side? So we can return errors and everything, and you see the return done, ampersand, etc. This is where I take just a slice of the input data and return it. I never copy anything. But it's kind of hard to write. So there's another feature that's really cool in Rust called the macros that I started to use because it makes the parser a bit easier to write. Basically, I have the name macro to define a function, and then it's just a chain of combinators. So here we have a simple one, but we have kind of bigger ones, like we have the mapres, which can take the result of the first parser and apply a function on it. We have the chain to accumulate parser results and pass them in the closure. So we can write some quite complex code very easily with those macros. We have the usual combinators, usual parsers. Some friends just contributed the begin sign parsers just yesterday. So I didn't have to write that. Cool. And with that, with a language that has those kind of features, we can get some interesting performance. So if you have seen the paper, it's just, I didn't write this to see, hey, NOM is the fastest parser ever. No, it's just to see where I was, and also to check what it was on the usability part. Basically, Hammer and NOM were a bit hard to write. So that's why I started to work on usability and macros and everything. Autoparsec and serial, which are written in Haskell, were just so easy to write and to understand, and quite fast too. So that's quite interesting, because at some point we would like to choose easier to read instead of fast, and maybe optimize afterwards. Basically, the autoparsec and serial parser are just 1 or 2 line different, nothing like that. And that's one of the biggest goals of my project. I want to make everything easier for the developer. Because there's not only parsing, there's all the handling the streaming and everything. Like, I presented the incomplete part in the enum. Is it still readable? Yeah, maybe.
One more step.
Yeah. Right. I don't know. Okay. So incomplete is interesting because sometimes you just want to tell, okay, I just need more data to understand the input. Because with the streaming RTP format or MP4, like this kind of stuff, more data will be able to come. So what we do after that, well, we have to handle string, and then it's not readable anymore. I'm sorry, there's a lot of code. Here's a pattern that I made easier for the developer, because once you have the incomplete, you can get all the plumbing to pass the data as it comes. Producer is just some kind of piece of data. The data comes like you're handling a file and goes all around the file, or you get data from a socket. The producer will handle passing the data to your parsers. If he gets incomplete, he will reallocate a buffer with the preceding input, add more inputs, try again, and all of this automatically. But it's not enough. We need something more powerful. So we have the consumers. The consumer is a bigger pattern. Basically, it's the overhand, and it's a state machine. You implement something that will get a producer and ask data, okay, I await 10 bytes, or I need to seek back in the input, or need to seek in the overhand. So you can do that. We have the plumbing for that. And basically, you will define your state, your parsers, and you write your state machine like that. So as an aside, this is a switch-based state machine. We all know that it's a very, very bad idea. I tried to play a bit with type enforced state machines in Rust. It's cute, it's fun to use, but basically, that's what Eric was saying. We need input-enabled state machines, so we need to have any message to come at any state. So that kind of state machine is not good. I should find a way to generate them for runtime checking. So I made it easier to handle streaming and that kind of pattern. But we can do better for the developer. Because the parsers are fun to write, but sometimes when you don't know what works, you have to do a bit of guessing. So for the debugging part, I tried to add some tools that could make it fun to write parsers. So let's use a first tool that we all know, the hexdump. So that's easy. You take a file, you put it in hexdump, and it works. Well, why shouldn't I be able to do that on a parser that I have in memory, or on a buffer? Basically, I see that I had an error with one parser. I get it slice, and I do a hexdump. This is the easiest one. I have the debug and debug dump macros. Basically, if the child parser returns an error, it prints the error. And the debug dump will also print the hex dump of the input slice. But it's not enough. We can do better for error management. So this is why I have some complicated types. At the beginning, in NOM, the error was just an error code and nothing more. Here we have the ability to show error codes, position in the input, and a pointer to the next error. What can we do with that? Well, we have the error macro. So this macro is kind of like the cut operator in Prolog. Basically, the problem we have with Parser Combinators is that if there's an error, it will backtrack and try another one and backtrack. And the parser that will return an error is the root one. And it gives you zero information on the parsing. So with that kind of macro, you can just return an error in where it should have. You return the error you needed to see. Because basically it will not backtrack, it will just do an error return. There's another trick in there is that if in the chain of child parsers there's another error macro, it will catch that error return, wrap it, add its own, and return. So that's how we have a chain of error that can be generated. Like, I don't know if we see, we can have a better one. So here we see that we have a few errors that I've embedded in each other. What can we do with that? The first thing we can do is pattern match. Basically, we take a chain of error codes and try to get error message from that. There's a problem with this. Pattern matching will break if the grammar changes. So there's a nice paper that we will see that's called MER. That's an error management system that came for many years in the OCaml parsers. Basically, the idea is that you generate error patterns from known bad inputs, and you use that as the error management system. So here I take some bad inputs that I know, I get the error that returns. I use that as a hatch map. If I get a list of error codes, I know directly the good error code. And a last fun feature that we can do with the chain of errors is this. We can see which part of the input in the hexdump is handled. So there's a problem with that is that it's a chain, it's a path in the parser tree. So we do not see contiguous parsers, but we see just parent, child, 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 child. But it's quite cool. I have to say it was very fun to develop, and it's quite cool to use. So is it usable enough? Well, I'd say yes, because people are using it. Oh, then it's too big. So basically, the INI, GIF, and MP4 were mine because I had to try it. But some guy that did the FastQ, which is a text format for encoding genetic data, libconfig, Thrift and Kafka for messaging format, some IRC one, and also a small company that you may know that has used the GNOME for some times. So some guy contacted me a few months ago. Hey, we do streaming HTTP parsing with GNOME, and it's quite fast. All right. So to sum up, we have a language and a parser library that is fast, that is memory safe, that has no runtime cost, no garbage collection, nothing like that. That can be embedded in C. I made sure it works, and has a lot of tooling for developers. So this is not very formal, but this is what developers like. Something that is easy to use, that has tooling, that makes the development more interactive. So you have the GitHub URL. I can take a question if you need. Thank you.
Could you go back just one slide?
Yeah.
Yep.
Thank you.
Well, questions, right? Truly a ray of hope, right? I was especially glad to see the usage slide, and know the story. Questions? No Rust programmers here.
Yeah.
Well, maybe after this day. I certainly do know that I'm going to try to write something in this language.
I guess I have one question. So I use Rust in one of my classes on programming languages. I'm using Rust in one of my classes on programming languages for grad students, and I was looking around for a parser, but do you think it's ready to, enough for grad students to use at this point? Or do they how much of a background does a student have to use your library?
It's quite hard to get a lot of concepts, most important about the memory, because the compiler is just too smart, and sometimes you don't understand what he means. Like there's some weird memory error that can happen, but it's not self-evident, and for a beginner it can be hard sometimes. But basically, it gets smarter and smarter, and makes it easier too.
Okay, thank you.
So I have a question. Have you looked at data structures that SSL TLS uses?
Yes, I'm not confident in writing a TLS parser right now. It may be doable, but basically I can handle almost any binary format right now.
Mm-hmm. So how deeply nested are the formats that you have parsed to date?
Well, the GIF one, when you try to get the image data, it's on a bit stream, not a byte stream. So, but that's not byte aligned. So you have some time to get 3 bits from the preceding byte, and that's quite annoying. The MP4 format is very, very ambiguous because there's some atom that has a tag indicating the length, and then another tag that indicates if it uses 32 or 64-bit integers, so that changes length, and you can have nested atoms. That's quite hard to write, even with Parser Combinators.
Mm-hmm. Did you have to introduce any new kind of combinators?
New ones? I don't know. Basically, most of the ones I use are already known. The error one was quite different because it can accumulate errors, but the other ones are quite classic. Yeah.
Mm-hmm. All right. Well, thank you.